Okay, so in the past we have solved systems of linear equations using graphing. So remember a linear equation. Using graphing is you have two lines and your solution is where the two lines point. I'll call it AB. Actually, XY is fine as well. That's how we solve them. Graphing, we use substitution, and we also used elimination or linear combinations. Now, the determinants that you've now learned about will give you one more option. Now, for 2 by 2 matrices, either one of those three options that you learned in the past would be fine. But if you have more than two variables, so if you have three variables and three systems, then that's when you're really going to want to use Cramer's rule. So let's talk about it first for 2 by 2s, and then we'll upgrade to 3 by 3s after that. So Cramer's rule for 2 by 2, a system. If you have a linear system, ax plus by equals, let's say, e, and cx plus df equals f. There's two things I want you to know. Number one is the coefficient matrix. That's the one that's created by your coefficients a, b, c, and d, because typically these will be just regular numbers, like 2x plus 5y equals 7, or negative 3x plus 7y equals 9. That's how we'll get our coefficient matrix. The other thing I want you to do is, or to know is, in order to solve for these variables, we're not going to graph, we're not going to use substitution or elimination. We can find the value of x by finding the determinant of the coefficient matrix and also the determinant of this matrix. Now, how do we get that? Well, when I'm looking for x, then I'm going to substitute this AF with the solution. So remember that these represented the x, the coefficients of x. These are your coefficients of y. But instead, if I'm looking for x, I'm going to use the substitution. The solution row. If I'm looking for y, then instead of these coefficients, I'm going to substitute the y's instead. I'm going to show you what that looks like in just a moment. The main thing we need to do is make sure that we can find determinants, which is what we did the last time. So this right here is the determinant of A. Let me write this. This is the determinant of A is the same thing. If I write like that, the two bars looks like absolute value. It'll make things a little bit shorter for me. Okay, so what do I need? Well, one thing I found in common from those last two examples is I need the coefficients matrix. So coefficient matrix is 2, 3. This is from the x's. And then I have 1, negative 2, and that's from the y's. It's the coefficients, 1, negative 2, 1, negative 2. I'm going to need the determinant of this. And from a previous lesson, we know we cross multiply. 2 times negative 2 is negative 4. Minus 3 times 1, which is 3. So negative 4 minus 3 gives me negative 7 for my determinant. So that's going to go on the bottom of each of those fractions. Now, I need to find two things. I want to find the x, and I want to find the y. I know from my previous slide that the determinant of a goes on the bottom, so negative 7 goes on the bottom. On top of this, it's almost the same as this, except for the coefficient one, if I'm looking for the x's, I'm going to replace the coefficients of x's. Now, instead of this 2, 3, guys, I'm going to put 1, negative 23. And then this 1, 2 will stay, 1, negative 2 will stay the same. Negative 7 is fine. And I'm going to find the determinant of this. So I'm going to cross multiply. This will be negative 2 minus negative 23. Simplifying, I have 21, adding the opposite. 21 over 7, negative 7, excuse me. So the x value is negative 3. I don't know why I put that in parentheses. Just negative 3 is fine. Oh, because I was thinking about a coordinate. My solution for this should be a coordinate. I know the negative 3 is the x part. I need to find the y part. And so to do that, I know that y is equal to that same negative 7, the determinant of A, the coefficient matrix. Now it'll be over, go back to your coefficient matrix. This 2, 3 now gets to stay the same, but now if I'm looking for the y, I'm going to replace the y coefficients with my solution matrix, negative 23. And I'll find the determinant of that. 1, negative 23, and I have negative 7 cross multiplying. I have negative 46 minus cross multiplying here 3. This gives me negative 49 over negative 7, so the y is equal to 7. So if I'm writing this as a coordinate, the x part is negative 3, the y part is 7. How do I know I'm right? Well, you can plug it in to here, and you will get 1 and then negative 23 when you do that. Okay, so if that's all right, go ahead now, if you would please, and try number 2. I'm just going to give you a quick reminder. First thing you need is the determinant of A, which is your coefficient matrix. So I'm going to have 4, negative 6, 1, 5. I'm just going to start you off a little bit. Cross multiplying, this is 20 minus negative 6. So if you could please find x and then find y for us. Press pause while you work on those. Okay, so if you were looking for the x, remember that you replaced these coefficients with a solution. So 4, 14, negative 6, 5, and then you get 104 over 26, which is 4, and you use your cross products. And then for this one, you replaced the y values, and you have 4 and 14 here instead, and you should get 2. Go ahead and press pause if you need to see my work for a little bit longer. And then if not, we're going to go ahead and continue. So, now that's all fun and great. In order to find these for 3 by 3, so instead of a 2 by 2 matrix, we're going to use a 3 by 3. This works if you have 3 variables and 3 systems. 3 variables and 3 systems. We will still get the coefficient matrix the same exact way that we did before. Noticing that this is my solution matrix. It's actually a 3 by 1 matrix. If I'm looking for x, I'm going to have everything here exactly the same, except this is now replaced with the solution. Otherwise, it's the same thing. If I'm looking for y, now y is replaced, because remember, this is going to go x, y, and then z. And so if I'm looking for z, then I have that. I'm still going to use the determinant of A, though, for each of these. One thing I forgot to tell you to grab is your graphing calculator. So if you can go ahead and press pause and grab that if you haven't grabbed that yet, and then we'll go on, because we're going to use calculators for these ones. Joy. Okay. So what we like about 3 by 3 matrices is that you will always be able to use a calculator for them. What we don't like is that you just kind of have to pay a little bit more attention to what you're doing. But one thing that we do know from the previous part is we still need the determinant of A, where A is the coefficient matrix. So what are my coefficients? Well, 3 for the x's, 3, negative 4, and 2. For the y's, you had 5, 8, and negative 5. And for the z's, you have negative 5, 5, and 6. I need the determinant of this. You're not going to be irritated with me because this is where I'm going to show you how to use your calculator. I'm going to be writing down the steps that we're using, probably right underneath it in red. So the steps that I want you to take are, and I'll show you what that looks like on this calculator. I'm going to use second x to the negative 1. So find the second button, clear. Second, x to the negative 1, can you find it? It's right here where it says matrix. If you don't find it, go ahead and press pause. And now here's the thing. I already have something in there. You probably don't, but we do want to go all the way to edit. So hit to the right twice, and that takes me to edit. So once you're all the way scrolled over to edit, it should highlight in dark, and go ahead and hit enter at number 1. Doesn't matter which one you choose, but I'm choosing this one. And my matrix is a 3 by 3. There's 3 columns and 3 rows. I'm going to hit enter. And now I have a 3 by 3 matrix to enter into. Now what I would like to do is to enter these numbers into this matrix. So go ahead and do that now. In order to get from one to the next one, just go ahead and press enter. So 3, enter, 5, enter, negative 5, enter, and then negative 4, enter, 5, 8, enter, and then 5, and then go ahead and continue. 2, enter, negative 5, enter, and 6, enter. And then you're like, great, I put the matrix in there. Next thing you want to do is go ahead and do second quit. And now you're back to where you were. And it's blank. Great, no one cares. But how do I get back to where I was? Let's get back to matrices. So you're going to hit second x to the negative 1. I'm going to write down my steps. Second x to the negative 1. So we did that part just to enter the matrix. And now we're going to do some calculations. So for calculation, second x to the negative 1. Actually, instead of calculation, I probably could have just hit math. So scroll over to math. Hit your arrow to the right for math. And what do I want? I want the determinant, so number 1. And you're going to hit number 1. And it's saying determinant of what? Well, now you have to put that in there. So you're going to go second x to the negative 1. And then hit number 1 because that's where we stored it. We put ours in matrix A. So go ahead and hit enter. And then it pops up on your screen. Once it's there and it's there correctly, you don't have to close that parentheses. You can just hit enter. And it's telling you that that determinant is equal to 369. Now, if you did not get 369, it is for mostly one reason and one reason only. And that reason is that you entered in something incorrectly. It's the only reason why you would have that. Actually, if you didn't get 369, it means I did something wrong. Actually, I missed that this was a -5, and so that's why my answer is wrong. What you should have gotten was 119, actually. Yikes. Let's see me doing it the right way. So here's how you edit. Here's a nice review. Go ahead and second x to the negative 1. Second x to the negative 1. And I'm going to go to edit, and I'm going to fix my mistake that I made on matrix number 1. So I hit enter, and this was supposed to be, I can just scroll over to wherever I messed up. So I messed up here. I'm going to make that -5 instead. Now, second quit. I'm going to do my second entry, and that calls that back up, and now it tells me enter. Yeah, this is what you should have got. 119. Sorry about that, folks, but now you know how to edit if you do mess up. Okay, so from here, I need to find each of these variables. So for x, I know the bottom is 119, and the top is that same matrix that you had over here, only the correct version, 5, 8, -5, -5, -5, and 6. And now the x values that were here, I'm going to substitute this in. So this is the 21, 1, and -16. When you are editing this, guys, so you're going to go math, matrix, and I'm going to edit again. I'm going to edit this one, and the only thing that needs to change here are the x values. So I'm going to make this 21, 1, and -16. And then I'm going to find that matrix. So I'm going to do second quit, and it's nice this is kind of already up here, so I can do second entry again, and then enter, and I get 238. So x equals 238 over 119. X is equal to 2. Then you'll do the same thing for the y values. I know that the bottom is 119. The top, now when you're editing, say second x to the -1, you're going to edit again, the same matrix. Now this time though, I got to put that y value back. So these y values, these x values need to go back to the original ones. That's 3, -4, and 2. And then now I'm changing the y values to this 21, 1, 16, 21, 1, 16. And then second quit, second entry, enter, and I get 882. I don't think that's right. Let me pause and check. Big takeaway, always double check. I put a +16 instead of a -16. So if you did that right, you probably got the correct answer, which was -238. So the y value is -2. If you repeat this again for the z's, you're going to get -595 over 119, which is -5. And then you'll write your answer. This is x, y, z, 2, -2, -5. Go ahead and try the last one on your own. Remember, you can use a calculator for 3x3s. And you can check your answer right here. Thank you so much for your patience, and have a good one.